Okay, students. Now the topic is Register Organization of 8237 DMA Controller. 8237 DMA Controller has registers: base address register, base word count register, current address register, current word count register, temporary address register, temporary word count register, status register, command register, temporary register, mode registers, mask register, request register. And the size of these registers are given here. Some of them are 16-bit, some of them are 8-bit, and one mode register is 6-bit long, and two registers are 4-bit long. And now we'll discuss the working of these registers. Base address register. The data transfer will start from some address. The original address from where the data transfer will be started will be stored in base address register. Base word count register will store the number of words to be transferred during data transfer. And these two registers are for each channel. Each channel will have base address register and base word count register. These two registers will store the original address and original word count for data transfer. The current address register. During the DMA process, which address is being processed, that current address will be stored in current address register. And what is the current word count during the DMA transfer is will be stored in current word count. Suppose the current the base word count stores 100, then it will perform the word count from 100 to 0 or 0 to 100. So if this address store 100, it will count total number of 101. Temporary address register and temporary count register will help the DMA controller to increment or decrement the count and address. As the DMA transfer will go on the process, the address will be changed and the word count will be changed. So the temporary address register and temporary word count register will help in incrementing or decrementing the count and address as well. Status register will show the status of device, whether the DMA transfer has been completed or any other pending request is there for each channel. The status of these transfer completion or pending request will be shown in status register. Command register will store the command word which will specify the operation of DMA controller. Temporary register will store the last byte during the DMA transfer, last DMA transfer. Mode register will help which mode is being used by the DMA controller. Mask register will tell whether the channel can be masked or not. Masking means disabling or rejecting, postponing, as we have discussed in maskable interrupts. If mask bit is 1, then the channel can be masked. The request on that channel can be masked. Request register will show the request status for each channel. So in brief, we have discussed all the registers in 8237. So base address register, as I have told, that it will contain the original value of the address, because whenever the DMA process will start, the address from where the DMA transfer should be done will be overlapped. So we have to restore some value. That value will be stored in base address register. Whenever auto initialization will be done, it means if the transfer will start again, then the base address register will help to tell the original address, and this original address will be copied to the current address register, from where the DMA transfer will start again. Status register, as I have told you earlier, 8-bit register. First bit will tell the 0 channel has reached terminal count. It means if it is 1, this bit is 1, then the DMA transfer for channel 0 has been completed. Same for 1, 2, 3. If this bit is 0, that means the DMA transfer has not been completed for channel 0. Bit 4, if fourth bit is 1, then it shows that channel 0 has some pending request to be completed, and same for channel 1 and 2, 3. Command register. Command register will decide the operation of 8237, and it shows many options, as first bit will tell memory to memory transfer, whether it is memory to memory transfer or not. Second will show the channel 0 address hold will be enabled or disabled. Third bit, controller is enabled or disabled. Normal timing is being used, or compressed timing is used. Compressed timing, when multiple T states are being compressed to perform an operation. Next bit will tell that the fixed priority or rotating priority, whether the priority encoder is using fixed priority method for each channel, or it is using the rotating priority method. Same next bit will tell the late write selection or extended write selection. These are the write policies. Next bit will tell DRQ sense active high or DRQ sense active low, whether this pin will act for active low or active high for a bit, because it has a bar on it, so it will sense a 0 or 1. And same for DMA acknowledge. Temporary register will hold the data to during memory to memory transfer, and it will store the last byte of the transfer. Mode register will tell which mode is being used. Starting 2 bits, 0 and 1 bit, will show which channel is being selected. So 0, 0 for channel 0. Next 2 bit will show the operation, what kind of operation, whether it is write operation, whether it is read operation, whether it is a illegal operation, or whether it is the transfer is being verified. Next bit will help in auto initialization. As we have discussed that it provides auto initialization facility. If this bit contains 0, it means auto initialization is deactivated. No auto initialization will be done after completing one terminal count or after reaching terminal count. So no auto initialization of DMA transfer. Next, whether to increment the address or decrement the address. And 6th or 7th bit will tell which kind of mode is being used by the DMA controller. As we have discussed that this DMA controller has 4 modes. One is single mode, block mode, demand mode, and cascade mode. Mask register request for each channel is being masked or not. So in first 2 bit we'll select the channel. So 00 will tell that about the channel 0, 01 will tell about the channel 1, and so on. And the next bit will tell whether it is being masked or not. If it is 0, then no masking will be done for the channel specified in 2 bits, 0th bit and 1 bit. If it is 1, then the masking will be done. Request channel will show the request for DMA service. It has 4 channels, so first 2 bits will specify the channel, and the next bit will specify the request. To set 1 for setting the request, or 0 for resetting the request. So this is all about the register working of 8237. Thank you.